And we were discussing about the single phase induction motor, and in single phase induction motor will be truly a single phase induction motor when the motor will run on a single winding. That is important. Okay, it has got no starting torque, we have seen, and we have convincingly seen that it cannot have any starting torque. Okay, for to incorporate starting torque you have to do something, but the point is when the machine will be running, it will run on a single winding, and that winding we call it. I am sometimes drawing here. Let me follow same rule. This winding is the main winding is there, and here is the main winding current I m, and it is excited from a single phase source. That is all. It should be like that. Now, to understand why this machine is having no running torque, but it still will have why it is not having a starting torque, but it will still have running torque. There are generally two ways to analyze the machine. One is called double revolving field theory. Analysis can be done in two ways. Analysis. Double revolving field theory. This is by one method. Another is called cross field theory. By these two methods it can be analyzed, of which in this class we will consider double revolving field theory, because if you adopt this method of analyzing, you can invoke all the things you have learned in three phase induction motor analysis. Simple. Now, in my last class I was telling, okay, it is there. Now, this situation nothing will change if I imagine that this is the rotor shorted, there is a main winding M, and there is another winding in quadrature, magnetic axis in quadrature, that is called A, but I will not excite this winding at all, only main winding I will excite. So, these and these situations are same, inactive, although its magnetic axis is different. Now, therefore, if you connect here an AC source, this winding which will carry a current of I m, V m is the supply voltage, and this winding, since I have not connected anything, that means I a is 0. No source is connected. So, I a is made forcefully 0, and therefore, these two systems are one and the same system. I will try to understand in this machine as if I will say it is a balanced two phase motor. These two coils are there. One coil is carrying a current I m, another coil is carrying a current of I a, which happens to be 0. So, the thing is I m is present and I a is equal to 0. Therefore, these two currents are these are the two sets are unbalanced. I can treat it as unbalanced two phase current. And then I will say this unbalanced two phase current can be broken up into a positive sequence current and a negative sequence current. So, I m, the main winding current, can be written as a sum of I m 1 plus I m 2 and the auxiliary current. Why it is called auxiliary, I am just arbitrarily now calling, we will see later why they are so named. I A will have its positive sequence current plus negative sequence current. This I m 1 and I A 1 is the positive sequence and it is a balanced two phase current, and the relationship between them will be, suppose this is I A 1 and this will be I m 1 and this is 90 degree. These two lengths are same. So, this I m 1 and I m 1 form a balanced two phase system. Similarly, I m 2 and I A 2 will form another balanced two phase system, but the phase sequence in this case is A m. In that case it will be M and A, that is auxiliary winding current will be lagging main winding current now. So, maybe it will be like this I m 2 and I A 2, and these two are same, and these are not same, this may not be same to this. So, this is the negative sequence and this is the positive sequence of current. Obviously, you can see that I A 1 here, if I write I A 1 will be equal to j into I m 1, 90 degree. Similarly, I A 2 will be equal to minus j I bar m 2. So, I put it here. So, or I A auxiliary winding current, if you rewrite, I will translate everything in M main winding current. So, I A 1 is j I m 1, I A 2 is minus j I bar m 2. But the case I have considered, I A is equal to 0. I have not connected anything to the auxiliary winding, only main winding is carrying current, that is I inherited this circuit, my thought process I am doing, okay, it is there only main winding, I will assume okay, another winding is there, because two phase winding machine analysis will be in the same line as that of balanced three phase induction motor. So, that was the reason you bring another winding identical same as M, but carrying no current. So, these are one and the same thing. So, now these two currents are, and this I A is 0, which means that I m 1 will be equal to I m 2. Magnitude of positive sequence and negative sequence will be same. And not only that, if you put it here in the first equation, this if you put it here, you can say this is I m bar by 2, this will be the thing, is not. Therefore, what I A 1, I m 1, these two currents forms a balanced two phase current. I m 2, I A 2 also a balanced two phase current. and and so what we can do now, we will consider one sequence at a time and try to see what is the thing. That is the idea. For example, this IA1 and IM1, if you consider to be present alone, positive sequence first, then I will say, okay, these coils, that is what I am telling, consider only positive sequence. Then I will say, oh, this is the rotor, this is main winding, this is auxiliary winding. Say that it is carrying a current of IM1 and it is carrying a current of IA1. Therefore, it will, and these two currents are balanced two phase currents 90° apart. So, it will produce a rotating field moving from the leading to the lagging phase, IA and IM. Okay. And the value of this field, synchronous speed, will be 2f by p, like this. Now, consider only negative sequence. It is carrying a current IM2, but phase sequence reverse now, and it is carrying a current of IA2. Separately I am considering, and here it is like this, that IM2, these two currents are equal magnitude, but this is the phase sequence. So, leading current is M2, therefore, there will be a rotating field here produced in the opposite direction leading to the lagging phase, and once again it will have a field Ns equal to 2f by p. But this rotating field will move in the opposite direction as that of this one. Is that clear? Now, see the interesting thing, and this plus this will give me this situation: main winding alone, no auxiliary winding. That is the idea. Acha. Now, suppose I say that if that be the case, let us also tell that rotor is rotated by, say, some external agency. I want to analyze the machine, let the rotor is rotating like this. Whether the machine itself has created a torque or rotating, I am not commenting on that. Let us imagine somebody is rotating in the clockwise direction with speed nr. At that time, what is going to happen? Now, for the positive sequence, I have assumed rotor is rotating in the same direction as that of the stator field Fs1 positive sequence. Here it is stator field negative sequence. Now, this positive sequence field Fs1 is moving in the clockwise direction, and this is also rotor is moving also in the same direction. So, we say, instead of calling it because of positive sequence and negative sequence, we say that this field will give a name forward field. Forward field. Which field is forward? The field, the direction of rotation of that field is same as the direction of rotation of rotor that I have assumed. I am still not sure NR will have some finite value or not. Let us suppose by hand or by some external agencies given it a spin, NR it is running, and this is the situation. Then NR is this speed. Therefore, the speed of Fs1 and speed of rotor rotation, their directions, they are same, and that field I am giving a name, forward field. And this field Fs2, which is moving in the opposite direction of the rotor rotation, let me call it a backward field. This I can always do, give some name. And mind you, this is a balanced two phase induction motor. This is also a balanced two phase induction motor. What is the sleep at which this motor is running? S equal to Ns minus Nr by Ns. What is the sleep in this case? Sleep in this case, it will be minus Ns minus Nr by minus Ns, and this will be nothing but, because Nr is we have used so many times Ns, if you put it, it will become 2 minus S. Looks like this motor is in somewhat braking zone or whatever it is. Obviously, from physical consideration, this torque acting on this machine will be in the same direction as the direction of the motor, and this torque I call electromagnetic torque due to forward field. And for this, rotor stator field is moving in this way. Therefore, this torque will be there. And then I will say that the net torque acting on the motor will be TEF minus TEB, because they will be acting in opposite direction, and so this is the net torque, T net. So, you know that there is a forward field, there is a backward field. From another consideration also I will bring that forward field and backward field concept. Mathematically it can be brought, but what I have done so far is that, once again let me go rather slowly. This is the main thing, only a main winding is there, but this is can be thought of as a balanced two phase winding on the stator, but this winding is not carrying any current, and this is the rotor. Then this IA is equal to 0 and Im, they can be broken up into a balanced positive sequence component, this one plus this one, and they can be related with main winding current Im, because here is the only supply, these are real things. I have applied voltage Vm and Im is flowing, and in terms of that Im I have been able to find out what is Im1 and Im2, hence Ia1 and Ia2. Then I have come to this one, and then I am telling there are this is the rotor, this is Im1, Ia1, they are now carrying current, and Ia1 is leading Im1. So, the stator field will be moving from leading to lagging, na? This is okay. Similarly, the backward balanced two phase current, these currents are balanced, 90 degree, it will move this way. Then I am arguing that okay, the electromagnetic torque developed by this motor, it is a balanced, look like a rotating field is there. So, electromagnetic torque in the same direction as the stator field, and this field, and I have also assumed some rotation of the rotor arbitrarily. Okay, let us assume it is moving at some speed nr in the clockwise direction. The field which is also in the clockwise direction, I have given it a name called forward field, and electromagnetic torque will be in the direction of the forward field. Similarly, these two will produce a rotating field, but the main winding current leads auxiliary current. So, from it will move in the opposite direction. Okay. And it is called a backward field. Now, then the net torque will be difference of these two, is that clear? Now, after getting this, I will be now telling what is the equivalent circuit of this machine. Equivalent circuit of this machine will be per phase will be R1, X1, Xm, X2 dashed and R2 dashed by S. What else? Per phase equivalent circuit, per phase. And per phase current is Im1, that is all. Similarly, for this machine, stator impedance per phase R1, X1, Jx1, X1, and then there is magnetizing branch referred to stator. This current will be Im2, and this will be X2 dashed, and then this will be what slip it is running, 2 minus S. So, R2 dashed by 2 minus S, that is all. Is not? Because R1 X1, R2 dash X2 dash, these two motors are otherwise identical, only thing you have phase sequence is reversed. What will be this voltage? Whatever will be the drop here, it is Vm1, positive sequence voltage. What will be this voltage? Vm2, negative sequence voltage, plus minus. What will be this current? Im1, and Im1 I have seen it is equal to Im by 2. Similarly, what is Im2? It is Im by 2, like that. Acha, what will be the value of this TEF? Electromagnetic torque developed by this forward field or forward motor, sometimes it is called. It will be this power, that is this current is known. So, I will find out parallel combination, find out this current square into R2 dashed by S. What will be the torque developed here? This current square into R2 dashed by 2 minus S into 2 phase, it is a balanced 2 phase motor. So, suppose I say that this current is IF1 and this current is IB1. How do I know these currents? Because I know these currents IM1 and IM2 parallel combination. So, torque will be net torque will be 2 into air gap power of this machine IF1 square into R2 dash by S, then another term IB1 square into 2 into R2 dash by 2 minus S, and that will be the torque produced. But see, this is the thing, it has come to like that. And why I have put minus sign here? Because from physical consideration I know these two torques act in opposite direction. So, negative sign is also important like that. That is this way I can calculate the torque, but I will go a step ahead, which is so tempting, you know, because you see this is IM1 which is IM bar by 2, this is IM2 which is also IM bar by 2. Then it looks like there is no harm if you connect these two in series. Let me do it here. Nothing will change. I will connect it in series IM1, IM2, and not only that, then you see if you connect them in series, this voltage is Vm1 plus Vm2, that means Vm. See, as I told you that I have applied a that unbalanced two phase system IA0 IM. I have broken up the currents into balanced two phase current, then I got this. Okay. Then I have, because it is a balanced two phase machine, therefore, equivalent circuit must be like this. It is also a balanced two phase machine, its equivalent circuit will be like this, and therefore, this is IM1, this is IM2, per phase equivalent circuit. And then I know IM1 is equal to IM2, and this voltage here will be the positive sequence voltage of M1, this is the negative sequence voltage of M. Therefore, why not connect them in series, and it will be like this. Now, this voltage is Vm1 and Vm2. Acha, I will do another important thing at this point, that this is a positive sequence per phase voltage applied. So, Vm, this actual applied voltage will also have a positive Vm1 plus Vm2, and that I am telling it will be the voltage drop here and it will be the voltage drop there. Now, in this network it is all nice, okay, you can live with this equivalent circuit. See, after all, you have applied to the actual machine, that is this machine, what is at your disposal, Vm and Im. So, in this equivalent circuit everything is fine provided you know what is what, but only disturbing thing is you have applied Vm, this equivalent circuit is taking a current of Im by 2. That may create some, I mean, is it possible to modify it slightly so that this current will become Im? Are you getting? Yes, it is possible. What you do is this, your voltage here is Vm, all the impedances this plus this, when you divide with Vm you get this Im by 2. Now, suppose I say I will keep this Vm same because Vm is the applied voltage and divide all the impedances by 2. Then the current drawn must be Im. That is now divide all the impedances by 2. Then you will see that okay, this is R 1 by 2, this is x 1 by 2, this is j x m by 2, this is x 2 dashed by 2, and this is R 2 dashed by 2s, and this one I am drawing below, that Vm 2, this fellow I am just drawing below. So, this will be R 1 by 2, x 1 by 2, this is j x m by 2, this one is x 2 dashed by 2, and this one is R 2 dashed by 2 into 2 minuses. Then what I am telling, and these two are already connected in series, plus minus plus minus, and here is your Vm, and then I will say this current must be doubled. That is what I am telling. This is the thing. So, this where our machine was like this, operating on single winding, mind you, you have applied a voltage Vm plus minus, this current is Im, and it was, I have assumed it is rotating in this direction, rotor, then this is the equivalent circuit of the whole motor. And there is no, even if there is no winding, this is valid, because after all that auxiliary winding what I talked about, I assumed it is not carrying any current. So, whether it is present or not is in no way going to dictate what should be the torques in the machine. So, the whole idea is this current you assume 0. Then we analyze this circuit IA and Im, unbalanced two phase current, because I am sure IA is 0. One may question, why not you broke up Vm and applied voltage 0 here? Never do that. You do not know, the voltage here may be there will be, because of this rotating fields are there. But I am certain about this fact, IA is 0 if you have not connected. So, that is another important thing. It is not that should I assume this is Vm is there, Va is 0, applied voltage is 0, but the terminal voltage between these 2 points may exist. When the things will be running, you have excited this, there are rotating fields, is no. Therefore, you start with this IA 0 and finite Im here, break it up and do the things. Okay, we will continue with this, go up to this. Thank you.